Normal distribution is a very important concept in statistics, since many datasets and phenomena follow the normal distribution. Thus, the normal distribution has great practical usage due to its occurrence from time to time again. Back from the last chapter, I am sure you guys familiarize yourselves with the concept of distribution. So just a recap, distribution is usually the short name for the full name probability distribution, which can take one of the three commonly seen forms. Tabular, which means tabulated in a table. So you usually have a table with a random variable, their value, and the probability. Graphical, usually in the form of a graph or a plot, or formula in form of a given formula with variables. Most people tend to think of them as letters. Normal distribution is a special distribution because it has a name, which is named being normal. In this chapter, we can see the normal distribution in all of those three forms that we just reviewed. But before we go into studying normal distribution, let us get used to some preliminary concepts that will make our understanding for this chapter clearer. The first section of this chapter will discuss density curves. So here we are introducing density curves. So what are density curves? Density curves are any kind of curve that satisfy these two properties. Property 1, the curve is always on or above the horizontal axis. Property 2, the total area under the curve and above the horizontal axis equals 1. So here I include a graph as illustration. You can see the horizontal axis. Then you have a curve on or above it. So it should not be below it. And then the total area under the curve and above the horizontal axis, as I shade blue here, should be equal to 1. The total area is equal to 1. But be mindful, the density curve does not always have to be curvy or smooth. It can take actually any forms or any shapes, like it can be rectangular or triangular or any shape you wish, as long as the two properties we just discussed are satisfied. So you may consider why density curves. They're important because the area underneath the density curve or the blue shaded region you just saw correspond to the percentage of all possible observations of any interested variable that you may wish to find that lie within any specified range of values. Like you already know, probability can range anywhere from 0 or 1 inclusively. Thus, the total area underneath is 1, corresponding to 100% chance of something happening, that the probability that you are interested in finding. So the density curve gives us a visual and computational way to find the desired probability or percentage. So I include some graph here to illustrate the probability of the density curve. So here's the density curve as you can see before. Here I just draw it curvy, but as we discussed, it doesn't always have to take this shape. It can be any shape you wish, as long as it satisfies the two properties that we discussed before. So um, here I have letter C, denote any number. The blue shaded area to the left of C correspond to the percentage or the probability of all possible observations of the variable that lies to the left of C or less than C. C here can be any arbitrary number. For example, I take C equal to 3 and the blue shaded area to be 0.5. That means 45% of all of my possible observation will be less than number 3. Another example. So here I have the blue shaded area to the right, and this arbitrary number I will call C again. As you may have guessed, the blue shaded area here gives the percentage or probability of all possible observation of the variable that lie to the right of C or greater than C. So let's say that I take C to be 5 and the blue shaded area to be 0.28. That means 28% of all my possible observations will be greater than the number 5. So don't be scared of letters. They just mean that they can take any values. So another example. So here my blue shaded area are in between two values, C and D. As you may have guessed, this blue shaded area gives the percentage or probability of all possible observation of the variable that lies between C and D. So it's greater than C because you see the area to the right of C, and it's less than D because the area is to the left of D. Pretty intuitive. So let's say that my C value is 2 and D value is 7 and the blue shaded area is 0.39. That means 39% of all of my possible observation will be between 2 and 7. So as you can see, don't be scared of letters again. They just mean that they can be any values that you wish. And the density curve is there to help you have a visual way to see how percentage and probability and area are all related. So the takeaway here is when you look at density curve, the area equal percentage equal probability. Okay, see you next time.